Hey everyone, so we are moving on to what's called the Rolle's theorem, which isn't quite as common, but the mean value theorem is a super important theorem that we use, kind of like intermediate value theorem, where remember when they have a name, it's something you want to remember the name of. All right, so use your calculator and see if you can figure this out. This one I thought was actually very tricky. I got 12. So all I was doing was I graphed on my calculator and saw where is it crossing the x-axis. It crosses a lot. So I said 12. I might be off a little bit because I really had to zoom in close. Okay, so here's Rolle's theorem. Let f be a function defined on a closed interval. F is continuous and differentiable. But notice it doesn't have to be differentiable on the endpoints, just continuous. And f of A equals f of B, then there is at least one number in C for which the derivative equals 0. So if you think about this logically, it makes sense. So let's say, I have a parabola, for instance. If my two y values are equal, at some point, I'm going to have, it's continuous, it's going to have to go up and then come back down, right? The derivative at some point is going to equal 0. And it could be anything, if it's like this, I have this point and this point. At some point in there, it's going to have a derivative because it goes down and then comes back up. The derivative at some point is going to be 0 in between there. So here's some visuals. So on this one, again, remember that the f of A and f of B have to be equal. So there's one answer here, two answers here, one answer for the third one, and then non-examples. Here, the problem is that f of A does not equal f of B, so that's not an example. The second one, this one, the function has to be differentiable. This is not differentiable because of the corner. And then the last one, again, f of A and f of B are not equal. So the big thing is the continuity and the differentiability between them. All right. So find the x-intercepts of f of x equals x squared minus 5x plus 6 and show that f prime of c equals 0 for some number c belonging to the interval formed by the two intercepts, and then find c. So this is Rolle's theorem. So it says find the x-intercepts. So if we set this equal to 0, and I factor, I get x equals 2 and x equals 3. So those are my x-intercepts. So f of 2 equals f of 3. So that means at some point between there exists a c somewhere in 2 to 3 where f prime of c equals 0. Because those two y values are equal, this is going to have a derivative that equals 0 at some point. So we find the derivative, set it equal to 0. So 2x minus 5 equals 0. So x equals 5 over 2 is the answer. Right? So at 5 over 2, it has a derivative of 0. Derivative of 0. And we know that because at 2 points, oh my god, my brain is not working. We have two equal y values. This is a parabola, so it's continuous and differentiable everywhere. So we knew there had to be a derivative equal to 0, a max or a min. All right, explain why Rolle's theorem cannot be applied. So pause the video and tell me. All right, so for A, first thing you want to check is the endpoints. Is that true? And this is the cubed root. So this is the cubed root of x squared. And those are equal. They're both equal to the cubed root of 4. But the problem is f is not differentiable at x equals 0. X to the 2/3, when you take the derivative of this, you get 2/3 x to the negative 1/3. So the derivative does not exist at 0 because you have the x in the denominator. So x is not differentiable at x equals 0, so Rolle's theorem cannot be applied. All right, and the next one. So this one is continuous, but g of 0 is 1, and g of pi is -1. The two y values have to be equal over the interval for Rolle's theorem. Okay, so that one's not used as much. This one's is very similar, but this is the really, really important one. Let f be a function defined on a closed interval. Again, continuous over the closed interval, differentiable on the open interval. Then there is at least one number c in the open interval a to b, for which the derivative equals f of b minus f of a over b minus a. Remember that this is our average rate of change. That's the slope formula, right? So the average slope, the average rate of change, equals the derivative at some point. And here's how I like to think about it. If I drive to school and my average speed was 65, I went above, I went below, but my average was 65. At some point, I had to hit 65. I didn't magically jump from 64 to 66. That's impossible because it's continuous. You have to hit it at some point if that's the average. So here's a picture. So if those are my two endpoints, at some point, the derivative is going to be the same as that line. So somewhere like around here, right? If I draw my tangent line, they're parallel. So we're looking so at some point it's going to have the same, and a lot of times the goal is to find that C, right? We're going to be finding that number where this is parallel. All right, so verify that the function satisfies conditions for MVT. So is it continuous? F is continuous and differentiable over -1 to 1. It's a polynomial. Polynomials are continuous and differentiable everywhere. Find the numbers C guaranteed by the MVT. Okay, so we're going to find the average rate of change. So f of 1 minus f of -1 over 1 minus -1. So let's see, f of 1 is 6 minus 3 is 3. F of -1 plus 3 plus 5, so it's 7. So I get -4 over 2, which is -2. So at some point, the derivative of this equals -2. So I'm going to take the derivative, 3x squared minus 3 equals -2. 3x squared equals 1. X squared equals 1/3. So x equals plus or minus √3 over 3. So those are my numbers guaranteed. So geometrically, at x equals √3 over 3 and -√3 over 3, there's going to be a parallel tangent line to the secant line. Right? The secant line from -1 to 1 is parallel to the tangent line at x equals plus or minus √3 over 3. Another thing to think about it is the average y value, right? Or the average slope. It's approximately going to be √3 over 3. All right. Use the mean value theorem to show that a car that travels 110 miles in 2 hours must have a speed of 55 miles an hour at least once during the 2 hours. So this is really just an explanation to show that you understand the mean value theorem. So pause and just write a few sentences. So speed is continuous and differentiable. Real life speed we're talking about, right? If distance equals rate times time, our average rate is 110 over 2, which is 55. At some point during the trip, the car must have traveled 55 miles per hour. If it's averaging 55, right? Because there's no way to average a number if you're mostly below it. Okay, one more. Same idea as before. Verify, does this work for the MVT? And then find the numbers, the number C guaranteed by the MVT. So this one is not always continuous and differentiable, but look at the interval. So f of x is continuous and differentiable over 0 to 1. And honestly, you don't really have to go crazy with it. You just got to state it, right? We don't have to prove it. Like, we learn all this stuff in Algebra 2 and Pre-Calc. We don't have to prove it. As long as you state it, that's really enough. All right, so I'm going to find my f of 1 minus f of 0 over 1 minus 0. So f of 1 is 1/2. F of 0 is 0, so I get a half. I'm going to set that equal to the derivative. I'm going to use my part C. The derivative equals derivative of the top times the bottom minus the top. Derivative of the bottom is just 1 over the bottom squared. So this gives us 2x squared plus 2x minus x squared all over x plus 1 squared. So we get 1/2 equals x squared plus 2x over x plus 1 squared. What I usually do is I cross multiply. So I get x plus 1 squared equals 2x squared plus 4x. FOIL. Get 0 on one side. Aw, man. Quadratic formula? Did I miss something? Is there an easier way to do this? I don't think there is. -2 plus or minus 4. Oh, it's root 8. All over 2. I'm just going to leave it like that. Wait, it has to be between 0 and 1. So the answer, it's not going to be plus or minus. It's going to be just plus. So my answer is x equals -2 plus root 8 over 2. We can simplify it, but I just don't care. And then again, geometrically, at that x value, whatever it is, I don't know, the decimal, it's not a calculator problem. The average rate of change is the same. Oh my goodness, my brain. The tangent line to the graph at this point is equal to the slope of the secant line, which is 1/2. So this at this point, the derivative of the graph is 1/2. All right, and there's your homework.